Okay, so in this video, I'm going to go over member functions a little bit more. I'm also going to talk a little bit about big O of member functions to kind of get you ready with writing your own. So we're going to go back to the R vector class and look at some of the complexity of those functions, but also just go over some of those functions a little bit more. So let's start with an easy one, which is the size member function. So the size function is in the public. It's a public function that the user can call. And I told you when we were going over all the container classes in C++, I said, okay, well, what's the complexity of size? Is that O(n)? Well, here you can see why it's not O(n) and it's O(1). And it's because all it's doing is it's returning the member variable associated with that particular object. So remember, the object carries around with it all of its data as well as all of these functions. So anytime you call on an object, it knows its size and it keeps track of it. So the size function is basically a getter, right? I said getters and setters. It's providing you access to a member variable that's private. And so when you call size, it's just returning that variable. And that's one of the kind of fun things about writing in classes is sometimes when you write a member function in a class, it's only one line of code. And so that's why size functions are big O of O(1). Let's look at pushback. Pushback, if there's room, which we went over in a previous video, and it doesn't need to be expanded, big O of pushback is O(1) because all it's doing is accessing an element of the C array and placing something in it and incrementing the size, which is constant time because no matter where you're doing that, it's always the same, right? So it's like a couple operations, the access, the assignment, the increment, it's probably like 5 or 6 total computations, but it's always that, right? Regardless of which one you're pushing back. On the other hand, if you require to expand your vector, remember that that's going to be a little bit more expensive. We went over this in a previous video, but if you don't have space, so let's say that you have filled up your 4 spots and now you're putting in the 5th element, you're going to need to start by adding capacity. So that's going to set the new capacity equal to 8, and then this call here is going to go ahead and get a C array that's 8 big. Then this here is going to copy everything from the old one into the new one. And then this is where you're kind of like moving around the pointers, right? So delete A is going to destruct the data that was here. You've already copied it over, so there's no problem. This is going to update A to now point to the new one, and then this will update your private member variable capacity. So in this case, because of this operation here of doing the copy, it's going to be O of n. Pushback isn't O of n in general because this only happens every time you need to expand. And so if you analyze it over time, it becomes basically constant when it's divided out through every time it's called. But there is some cost associated with a pushback function, right? And that's that copying when it expands. Another function that you can check out in the R vector implementation is the at function. It basically works exactly the same as the operator square bracket function. All the function does is it does an out of bounds check, so it makes sure that you are within the indexes that are valid within the array. You have to do this if you want to make good abstractions, right? Because C arrays allow you to do whatever you want, but the idea of making a dynamically allocated array is that you handle that for the client. So the first thing it does is it checks to make sure it's in bounds. If it isn't, then you just get to directly access this vector, right? So we have A here, which is pointing to this memory, and because you're inside the implementation, you have direct access to it. And so again, sometimes when you're writing these abstractions, the functions are so simple. And this is a big O of 1 because that's the advantage of using arrays. Arrays allow you to direct access to the elements because that pointer arithmetic is overwritten. I mean, not really because it is, but that's just the nature of arrays, is that they're sequential memory, so you know where you need to go in memory at any given time. An example of where an @ function would not be big O of 1 would be if you were using a linked list instead of a C array, because you'd have to walk through the list in order to find element 5, right? Just a heads up that, you know, we've been talking a lot about public member functions because those are the ones that you're going to be really thinking about, and it'll be really easy to understand because you have been using these functions, right? But when you write your own abstractions, you are allowed to have private member functions. You just put them in the private section. And so anything that you add to your code, any helper functions, you're going to want to put those in private because they're not part of the behavior of the code that's spec'd out. And so there shouldn't be any reason that the user of the class should have access to those. And you should have helper functions, just like you should have helper functions in any code that you write. And so just make sure you put those in the private portion of your code. All right, so that is it for a little bit more information on public member functions and their big O.